Hello friends, I welcome you all on my channel. In this video, we'll discuss to do two sample t-tests. In last video, I discussed how to do one sample t-test. Here we'll discuss how to do two sample t-test. Okay friends, before that we need to know why do we use that. Uh, First of all, we will be discussing two sample t-tests in this video. Uh, the application of this video, this two sample t-test is if we want to test the difference of mean of two independent samples. Friends, we are having two independent sample, we are taking mean of them, and what we are doing here, we are comparing the mean of their, is it different or not. So simply when you want to test the difference of them is significant or not, we would do are they different from each other statistically, we do a two sample t-test. Assumption are normality and independence. Both the samples are independent. uh, the selection of has the selection of one of them has uh, no bearing, no impact on the selection of other. So now how to do that? So I'm using Excel for that purpose. So here I have generated two samples, sample X and sample Y. Here I have generated two samples, sample X and Y. In one sample I have taken 100 observation, and in second I have taken only 50 observations. So here friends, here I can see, if I say you here, sample first is 100 observation, sample Y 50 observations, and the mean by average function for both of them, and sample standard deviation by standard deviation function for sample I have computed for both of them. So here we have two samples of different size, it could be of same size as well, and then their mean and their sample standard deviation. These are the input we require to compute two sample t-test. Okay, so we want to test, are their mean we are like 9.72 and 9.82, are these means we are getting from different samples, are they statistically different from each other or not? So for that purpose we are having null hypothesis. We are saying that both are same, it could be anything. It could, here it is two way, uh, a two tail t-test, it could be greater than or less than symbol as well, one tail t-test, but for ease of understanding, for ease of making it more clear, I'm just taking two tail and I'm saying both are equal. So, and other way I can write it is mu x minus mu y is equal to 0. So here I'm saying both sample are having same or identical mean, they are not different from each other statistically. So simply as in one sample t-test, what we had here, x bar minus mu divided by sigma by under root n. So the same thing applies here. This is our sample things, these are our population hypothetical mean, we are saying here it is equal to 0. So therefore it is 0 and we are removing it, and we can write x bar minus y bar, that's all, and divided by, here we had sigma by root n, and here we have two sample, so 2 sigma we have, 2 n we have. So what we have done here, divided by s1 square by n1 plus s2 square by n2. S1 is standard deviation of first sample, S2 is standard deviation of second sample, N1 is number of observation in first sample, and N2 is number of observation in second sample. So this way we can compute or measure, and we can get some value here, and this value coming here is this one. The t-test value is here. This is our t-test value. This is for one sample, so I'm not just like we get here. So it is for two sample t-test. This is our two sample t-test. The formula for this calculation we have put, and we are getting a value that is minus 0.09, and here 0.019, and here the value we are getting by for this two sample test here, T inverse 2 tell, this is the function for that, just computing critical value for t test, and then degree of freedom is for 5% level, f2 plus g2, that 100 plus 50 minus 2 we are taking. So the value we are getting 1.97 is critical value, and the computed value is 0.19. Since computed value is less than critical value, we cannot reject the null hypothesis. So here our conclusion, we cannot reject the null hypothesis, and sample mean here is not different statistically. Both the means are not different, they are same, actually they are not statistically different. So in summary friends, we are having two samples of, it could be of same or different observation size, and their mean and standard deviation, sample standard deviation friends. And then some null hypothesis, this could be one tail or two tail. Then this formula, we get some computational value, and then some computed value of t statistic for two tail, one tail, and their critical value. If our computed value, absolute value is more than our critical value, then we reject the null and say the means are different. Thanks friends, keep watching.